Hi there, this is Mr. Mack. This is the first video for AP Calculus this year. It's about the material covered in the book on page 84, chapter 2, section 1. And we're talking about tangent and velocity problems. Now, the first question that comes up is about tangent lines to functions. If you have a function, and let's see if we can't come up with some kind of a curvy type function here, you might ask yourself, what is the slope of a line that would be tangent to the curve at a particular point? And so what we do is we say, well, what we're going to do is we're going to call this point, we'll call it x. And this is the function f of x. And then we'll have some distance here, say h. And so this point on the horizontal axis would be the point x plus h. And this height right here would be f of x plus h. I guess I didn't mention that this distance right here would be f of x. And so the line that goes through, I need to work on this just a little bit here, that goes through having a little trouble there. Let's try down here. There we go. There we go. The line that goes through these 2 points would have a slope. Let's say that the blue line, the slope of the blue line. Now, we call this the secant line because it actually goes through 2 points on the curve. The slope of the secant line would be f of x plus h minus f of x over x plus h minus x. Remember, the formula for slope, if you have 2 points, is the slope is equal to y2 minus y1 over x2 minus x1. Well, remember, y2 is this distance right here, f of x plus h, and y1 is this distance right here, f of x, and x2 is this x value, x plus h, and x1 is this x value, x. Now, notice in the denominator that the x's go away, so the slope of the secant line ends up being f of x plus h minus f of x over h. Now, it is, you've seen this before because a lot of Algebra 2 and a lot of pre-calculus books have you evaluating this from time to time, and they call this the difference quotient. This is a very important expression, and the idea, though, is this, that as h gets smaller and smaller, x plus h moves towards x, and the point moves along the black curve around towards, the second point moves towards the first point, and so the slope of that secant line gets closer and closer to the slope of the tangent line. And it seems reasonable to us to say we're going to define the slope of the tangent line to be equal to the limit as h increases without bound, as h approaches 0, as h approaches 0 of f of x plus h minus f of x over h. In other words, as this h gets closer and closer to 0, this expression right here gets closer and closer to the slope of the tangent. Now, this is the very first video I've recorded in this fashion, so I'm going to stop it here, and there will probably be a second one, but I just need to check to make sure that I haven't been doing all of this for nothing. So, Mr. Mac out.